Hi, so today I'm going to talk about three different ways that you can optimize your project. And I noticed that most people don't use one of these three, and I think that one is actually the most important. So we're going to cover that. First, let's start with general definitions. So, what I mean by hotspot is basically when you optimize critical points in your project, meaning something that gives your project stutters or is expensive, and it can be exponentially optimized, meaning you can make it 10x faster, 100x faster, stuff like that. So it's few points in your project that maybe freeze your game for a second or something like that. Really expensive stuff. So by local, what I mean is generally optimization of your functions and events. So hotspot can be just a small part of a function or an algorithm, and local means your whole function, your whole event, general cost of different elements of a class, essentially. And by structural, what I mean is how your project is actually structured. How do you use different things like inheritance, components, interfaces, data tables, stuff like that. And also how you structure functions, what you put where, and all the other stuff. So let's start with an example. Let's say you finished your game and you have some issues. So you're ready to release, but when you play your game, you have 25 to 35 FPS on a decent PC, and there is also occasional stutters or FPS drops. In here, you decide to go into your game and try to diagnose what is creating some issues. And what you find are a few things. So we can say that on this graph, the higher means more milliseconds per frame, meaning lower is worse. So you play your game and you find that you have some really expensive stuff, maybe an algorithm, or maybe you were using wrong data structure that made finding something 100 times slower, stuff like that. You go in there and you fix it. You basically find your hotspots and you minimize them, decrease their cost. Now you have smooth out curves, so you don't have those stutters, you don't have those FPS drops. Now, good thing about hotspots, it's generally easy to deal with them a bit later in the project, so you don't have to think about them up front or deal with them up front. Usually there are going to be times where hotspots are also maybe like local or even structural, and you do have to think about them. But in general, hotspots usually mean like an algorithm is really ineffective, so you need to use another one or something like that. And they are usually pretty obvious. So if your game freezes for 20 frames, you're going to notice that. If there is a sudden frame drop, you're going to notice that. So usually hotspots are decently obvious, and you can catch them. For this, I'm gonna give you an example. For local instruction, I'm not gonna give an example because that might take so long and I don't want to create a really long video, but I'm gonna explain what I mean and then you can figure out what would optimization for that be. But let's go into a hotspot. So I'm gonna put a hotspot actor in the level. So we have it in there. And what I did with the hotspot actor is I have an array and I just put 20,000 integers in there, and then I'm running array find function. So I'm just basically trying to find number 18,000, and if we find it, we just break the loop. If we look in here, if we know that there is 20,000 indexes in the array, and we are basically adding these indexes for each value, we know that we're going to have to loop through 18,000 entries in the array and then go to our point. So if we run this, so I'm going to go to output, let's press play, and let's increase this. So we can see it was a bit expensive, so I'm gonna play again. I think it should be a little bit less. Okay, so it's decently expensive, probably because I'm streaming. But as you can see, it is really expensive. So we can see this even more. Hopefully it doesn't crash. But if we do this on Eventic, and you can see the FPS in here, so let's press play. And you can see because of the cost, my FPS is gonna drop to probably like 3 FPS, because you can see in here how much time it takes to generate it. So our game is suffering a lot. So let's try to optimize it. I'm gonna go to array find, and the biggest issue is this. So in blueprints, for loops are pretty expensive, and this is also for loop with breaks, so it's even more expensive. And we're kind of trying to do this operation, and let's say somebody did this really fast and screwed up. They didn't know that you can actually just do find item or contains. So let's do this, contains 18,000, and we can connect it to this. And we can disconnect our thing here, and I'm just going to take the branch here. So now if we run this, let's clean this up. Now if you run this, you can see that our expense for searching stuff decreased by a lot, probably by 1,000 to 10,000 times faster, just changing this. Stuff like this would be an example of hotspot optimization, where you find way better ways to deal with something. Now, this was kind of a dumb example just because obviously you're probably going to use some native function that was actually optimized, not manually try to for loop. But there is going to be a situation situations where maybe you have an array and actually a map would be better, or you have a map and array would be better. So you just have to test and see what is happening. Why is your function or algorithm so expensive? Hopefully it makes sense. Okay, let's go back to the list. So you do your hotspot optimization, and now you remove the stutters, you removed the FPS drops, and you also maybe increased your FPS a little bit. Maybe some hotspots were in functions that were frequently executed, so you maybe went from 25-35 to 30 to 40 FPS. So you're still not satisfied. There is fluctuation in your frame rate, and it might be a little bit low. You want it to be higher, so you continue optimizing. So you go then to local optimizations. Now when you're going to this, you're gonna go over a lot of functions in your project, probably hundreds of events, functions, and this is probably gonna take way longer than hotspot optimizations. But what we can do with this is find all of the functions and events that are expensive, but they're not that visible. It's not that obvious that they are the sole reason that the project is lagging or stuttering. So you try to diagnose your project, find some functions that are problematic, fix them up, and you smooth out the curves. Your game is now more stable, a little bit better. For local optimizations, they're usually a little bit less obvious than hotspots, and you should start working with them more early in the projects. You probably don't have to start optimizing them in the first week or two when you start working, but after a few months you should start caring about performance of your functions, even like smaller optimizations, because they're gonna pile up and you're gonna get more and more issues over time. After we do that, we stabilize it to, let's say, 40 FPS. And it's nice, but you want your game to run at 60 or maybe even more FPS, so 60 plus FPS. Then for that, you start looking at your structure. You have your game at 40 FPS and you are thinking how you can structurally improve your projects. And here comes the issue. You look at your project, maybe you have some inheritance tree for your characters, and you realize, okay, to optimize this character, I will have to completely break the structure of the character. I cannot have these 4 layers of inheritance. I cannot have these 15 components I have on the character. I cannot do all of these interface calls. I have to restructure it completely. And what's going to happen is you're going to realize that that is not going to happen. You're never going to, at the end of your project, now say, okay, I'm going to break down 55 classes in my project and hope to kind of restructure it. So structural changes are the worst for late optimization because you're just not going to do it. What's going to happen is you're probably going to start your project from scratch and try to make it more optimized in the beginning instead of trying to break down the structure. So the biggest issue with structural optimization is that it is invisible and it needs to be done early. Invisible meaning if you, let's say, start working with some structural that might be problematic in the future, while you're working on it, you're probably not going to feel the effects of structural performance issues. They're going to be silent and they're just going to take 1 frame a second from your project every week. That's all that's going to happen. So you're going to start with, let's say, 120 FPS, and after 6 months, you're going to be at 80 FPS, and after a year, you're going to be at 30 FPS. That's what's going to happen. So you're just going to silently start taking away your performance. And that's because when you build up your project, rarely it's going to happen that you add new stuff and your project is more performant. Usually, the more things are in the projects, the less performance is going to be because it needs to deal with more stuff needs to be processed. There are exceptions if you add something like a plugin that optimizes something or whatever, but in general, it's going to be taking away performance. The structural one is something I don't see many people thinking about or working on. I see a lot of people starting their projects not thinking about performance, thinking that they can do like a stage 3, I'm close to release, now I'm just gonna increase my performance from 35 FPS to 65 FPS, and that just doesn't work. At best, you're gonna go from 35 to maybe 45 stable, maybe, if you do the local and hotspot optimization, but in general, you're just gonna have to deal with your structure and hope that the next project you care about it early. So this is the ideal that you wanted with this hypothetical project. You wanted to be 60 plus FPS, but unfortunately we couldn't manage to do it. We got a stable 40 FPS by doing local and hotspot optimizations. So now the big question is, how can we get also the structural optimization? So let's go through that process. So the process is actually pretty simple. We already went through it. We just need to reverse the footage. So what we need to do is first start with structural optimization. You need to think about what you're using, how you're using it, and what is the minimal amount of code that you need to add to your project to make the feature you want to implement work. Some really easy things is I talked in one of my previous videos about binds in widgets. If you, let's say, have a health bar and you bind a function to that health bar, that means that binded function is going to tick however times a second, let's say 6 times a second all the time, but your health maybe needs to be updated only once every 10 seconds. That basically means that you are wasting, what is that, 600, your binded function takes 600 times more than what you need. So that might be like an obvious one, but there is a bunch of stuff like when you are making, let's say, your character, you need to ask yourself, do I really need inheritance, or can I solve it in a more efficient way? Do I really need all of these components? Do I really need to have a bunch of interfaces? You need to think about your structure and ask critical questions. Do I really need this? And why do I need this? I need to justify whatever I'm adding. And while you're doing this, you probably won't gonna feel the performance wins right away, and that is why you just need to trust that your project is gonna suffer less in the future. And this is an unfortunate thing where hotspot fixes can be really satisfying, while structural ones you're probably not gonna feel for some time. And even at the end of your project game might run at, let's say, 70 FPS, and you might think, okay, this is nice, but not a big deal, I was just making my project. But maybe if you weren't thinking about the structure of your project, it might have been running at 40 FPS, but you don't feel it because you just feel the 70 FPS. So it's hard to feel, but you just need to trust that it is doing something, that your structure actually matters for performance specifically. And while you're thinking about performance and doing stuff, you also need to just pay attention. You don't have to think too much about optimizing functions all of the time, but you still need to occasionally to see, okay, this function feels like it's a little bit too big and it's gonna get problematic, so I probably need to spend one day more trying to make it really nice and functional. So you can catch while you're making stuff. And also, big thing is, if you ever feel like something is possibly gonna be performance, you should always try to test and see, is that actually happening or not? Because something could feel like it's gonna be unperformant and maybe it's not, and something else might feel like it's going to be fine but it's actually really performant. So every time you just assume something is performant or not performant, you're making guesses, and guesses are pretty bad because decent amount of time you're going to be wrong, and then you're going to build assumptions on top of assumptions, and then you're going to have in your head a bunch of stuff that are completely wrong. So just be careful with that. And also, while you're working on this, when you come to the hotspot stuff and you find some really problematic stuff, now that you have your structural stuff taken care of, you have your functions decently optimized, now when you hit those hotspots at the end of your projects, they're basically going to be your only performance issue. So then when you deal with them at the end, you have generally decently performant game. And just to come back to the structural optimizations, these types of optimizations, how I personally do them is just get into the habit of, while I'm making stuff, I'm making it already performant. So meaning I have tested what is the cost of the cast, of the interface, of finding something in an array, of finding something in a map, of using inheritance and calling virtual function, overriding stuff. So I did some tests on that. I have in my head more intuitive sense of what something is going to cost or not cost. So that is also something that for this stage, you need to test stuff and get into the habit of already figuring out what is actually expensive, not expensive, and then creating your project by default in decently performant way. Any blueprint that I'm creating for my project, I try to make it 7 out of 10. It doesn't need to be 9 out of 10 code, like the perfect thing, because then I'm probably wasting a lot of time on something that I might not get decent enough gains. So just try to make it good enough, and later if I need to push it a little bit more in some places, that's fine. But if you just create a 7 out of 10 code, your project will be fine. I think most people start with kind of prototype code and just keep it, so 3 out of 10, 4 out of 10 code, and then you keep it and hope that at the end of the project they're gonna transform it magically from 3 out of 10 code to 7 out of 10 code or 8 out of 10 code, and that's just not gonna happen. So you just need to make it decent quality all the way, the whole time you're working, and at the end just deal with some hotspots or local issues, and that's kind of it. So yeah, hopefully this helps you, and if you have any questions, you can leave them in the comment.